Alright, hello everyone. This is my second update video on my isometric game that I'm making for the CoCoCREW CoCoFEST Contest. Um, so I just wanted to give us a little bit of update on some of the technical things I ran into and kind of how I went about solving them, in case anybody's interested in that. And then I'm going to show you where I'm at as far as my current play screen for the main game, what that looks like, the elements of that, and then going forward from there, what the next things I'll be looking at to do are going to be. So, as you can see on the screen in front of you, this is the drawing of my isometric diamond-shaped grid. It's a 10 by 10 grid. This is going to be essentially the play field for the game. This is a screen capture I took, just so when I had this issue, I took a screen capture so I could see where my problem was, so I can make sure that number one that I resolved it, and then also to make just to be able to show what the problem was. So as you can see on here, I guess let me go back up a step. So every one of these isometric tiles that's being printed here, or I should say blitted here, is actually a square that extends out past the edges of each one in this shape like that. And so the point where this this top tile is actually being uh, being started to being drawn at is somewhere around where my arrow is right now on the cursor. So what happens is this one, when it draws, extends to here. When this tile here gets drawn, its box extends over into this box. I'm sorry, over into this tile, and you have a layering issue that you have to resolve. So in my previous video, if you watch with the screen that allows you to set up for RGB or composite, these white blocks were not as noticeable because the background was white, so you didn't really notice it. When I first started doing this, the layering effect was very noticeable. You could see the edges of all the boxes as they populated in. So I went in, found the routine that does the drawing of these, well, drawing of anything that you blit with the um, the software that I'm using, and it's inline assembly. So I originally went in there and worked out what I thought was correct, and then when I made this, as you can see, I still had these white spots. So it's obvious that anytime we have this color, a color, printed next to white, which is actually 0, uh, in the color scheme for color 0, or I'm sorry, I guess it would be color 0, or yeah, color 0 is white. Well, it also happens to be that anywhere you see a black spot here, that's also a 0 in the bitmap. So 0 is essentially my transparency color for all my tiles. Problem is, if you see white printed, I'm sorry, a white pixel drawn like we have here on all these, that means that somehow the assembly code is placing a 0 into one of the two nibbles of the screen memory byte to draw white, because I should never, from my bitmap, I should never get a white drawn pixel, because because 0 is basically essentially draw nothing, and it just should pick up the existing screen color for that nibble and goes through some bit transformations and puts it back down into the byte with that same value, if it's a 0. So obviously there's a problem going on here with getting these white pixels, and I guess to make a long story shorter anyway, what I went in and found out that what was happening was I was doing a bit well, two things occurred. I was doing a bit transformation with ands and ors and compares. And what happened was the uh, transformation, if it was successful, would transform the, well, essentially would change the value that I started with, which was the value of the the value that came from the bit of the the byte on the sprite tile map itself. So it would change that value. I would compare against to find out if it was, I can't remember what the situation, but if one of the two nibbles was 0, and then uh, I forgot to put take the original value and put it back into A, which is the register that holds the source byte of the pixel. I'm sorry, of the tile, before I pushed it out to the screen memory to be plotted. So I found that error. I fixed that. The other error, which was a little harder to find, and I couldn't quite figure out what was going on with it at first, was that I had a problem where if I would check for I would do a comparison for any tile byte value that was greater than 16. And if it's greater than 16, that told me that it wasn't 15 or less, which I had already previously tested for, and it was greater than 16. So then I knew that I could test the 2 bytes and figure out, which one, which if either is 0, and then if the one is 0, then it would pull through the transparency color. If not, then both the numbers would move on. Well, what I didn't realize is that you can only use certain branch functions, branch opcodes, I guess I should say, with uh, compare functions or compare opcodes. And I was trying to use like the BLT and the BGE, branch less than, branch greater than or equal to, those type of things. I was trying to do those with a compare, and they'll work under certain conditions, but not all conditions. So I ended up going into the Lance Leventhal manual. I don't know if you guys saw or you guys have that or ever read it, but it's kind of like my Bible for 6809 when I have issues. Went in there, looked at it, and basically comes back that there's 4 choices that you can use of branch functions for a compare, a branch opcodes for a compare opcode to test its result. And when I changed it to those, then that cleared everything up. So to move on, my current game screen right now looks like this. This is the running game MAME. As you can see, this upper left-hand corner, this is what we call the play field. It shows the 10 by 10 isometric diamond, and then the green tile in the middle here would be the essentially the player cursor that'll be moved around to do different things on the diamond during the game. As you can see, all the white is gone. Everything does transparency as it should. I did a bunch of things like pushing different colored text like this over here, and everything does transparency well as far as I can see. And it's also drawn in a way that I can do transparency pretty much for any background value with just a few changes in software. So right now I have the black background. Not sure what I'm going to use for that. Obviously, in the play field, there'll be much more color depending on what's going on. Probably make this area out here a greenish grass color, just to show, outside of the garden grass, and then obviously inside will be more specific textures and such. Just to explain the game field a little bit, down here is where we at. We're almost at 10 minutes. I don't make this too long. Down here on the left is your storage. So as you grow and harvest crop, this number will go up. I have it set up for a maximum right now of 3 digits, so it'll be 999, although I don't think, at least in the initial portion of the game, that will be an issue that'll get reached. Up here in the upper right hand corner, this is your selling point values. This is essentially what you can get in dollars for selling one unit of your tomatoes. So all these, as you can see down here, like tomato, melons, pumpkins, and corn, and there's the number here. That's a unit of that crop. You can look at it as a bushel or whatever you want to call it, but it's I'm not being that specific for the game, but it is going to be a unit. And then up here there will be a value that you will be able to sell your crops for that value per unit. Then down here in the center we have cash, which is your amount of cash that you will have during the game. Then there's an AI cache. The AI is going to be essentially competing behind the screens, and your only indication of what they'll be doing, what they're trying to accomplish, will be through the number, through their cache number. What else? So the idea is that you'll start the game with a certain amount of cash, as will the AI, and with that amount of cash, every time you plant a plant, you'll have to pay a fee for seed for that plant. I'm not sure what those numbers are going to be yet. That's still to be determined. Same thing, the AI will have to pay it as well. And as you buy your seed, grow your plants, harvest your plants, and sell your plants, your cash value will go up and down. And then I'm going to pick a number through testing to find out what seems like a good number for a win condition, and then whoever's to that value first, whether it be the AI or the player, will win the game. There's still, as you can see, a huge area down here on the right hand side. I may use that to try to do a mini map of some sort, just to see how see what that looks like. But I don't know what I'm gonna just to put a mini map. I probably won't necessarily put it in the game, but I might just do it there because a mini map is a fairly essential component of larger isometric games. So I'm going to look at doing that, or maybe I'll find something else that I need to put down there for information, and we'll see what that ends up being. So that's about it. We are at 12 minutes, so I don't want to run any longer. If you guys have any questions or comments, please feel free to leave them. And I will get back to you guys when I have another update. Thanks a lot.